So in this video, you are going to solve question 1 from tutorial sheet 1. This tutorial sheet from Mulungushi University. I don't know where this university is, but I just got it for the sake of quality. Just want to be teaching each other. So in this video, we're going to solve this question. It's from the topic limits, precalculus. So many people asked me questions on how to solve this function, the limit as x approaches 0 of this function x over the modulus of x, question A. Let's get straight to our solutions. So before we start doing this, make sure you subscribe and like the video. Also share it to your friends. It might be helpful. So question A, find the limit as x approaches 0 of x over the modulus of x. Now, here the question was asking us to explain why the limits do not exist. This is what you should know before doing this question. Say, when you have been given a question, find the limit as x approaches a certain constant of a certain function, let's say fx. The limit as x approaches c from the negative. So when there is a sign there, it's from the left. It's coming from the left, approaching a constant c here. So when the limit of this function f of x is, when x is approaching c, it should give you L, which is the limit answer. And also when you approach this x from the right hand side of the same function, it should give you the same answer, which is L. If it gives you the same answers from the left hand side and from the right hand side, it means the limit exists. Unlike when it gives you different answers, which means the limit does not exist. So let us try this one. Take note of this. This might help you. So let us prove this one, whether it exists or it doesn't exist. So how we are going to go about this question is that we'll say the modulus of x is equal to x when x is greater than or equal to 0. And this modulus of x is equal to negative x when x is less than 0. So let's do this. Let me just copy this question. I paste it here. Okay. So let us solve this question. Let's say, let us find the limit of this function as x approaches 0 from the left. So let's do this. This is 0. Then the limit is approaching, x is approaching 0 from the left. This. So which means here x is less than 0, which is equal to the module, which means the modulus of this will be equal to negative x, as we said here. When x is less than 0, the modulus of this is equal to negative x. So answering this one, we are going to substitute. Where there is this modulus, we put negative x. Then x into x is 1. So here the answer is negative 1. So let us prove this one from the right hand side. Let's say limit as x approaches 0 from the right with the same function. So approaching 0 from the right hand side, it means we are approaching it from this side. And going back to our rule here, which says the modulus of x is equal to x when x is greater than or equal to 0. So which means this is a positive number. So when you are coming from the right, x will be positive. Hence, evaluating this limit will be like this. Where is the modulus of x, will put x. Here it was negative x because it was approaching it from the left hand side. So in this case, approaching it from the right hand side, the modulus of x will be x, which will give us 1. Now, if we get back to this rule I gave you, which determines the existence of the limit, you may tell that if the answers are same, the limit, when you find the limit from the left hand side and from the right hand side, they should give you the same answer, then the function exists. Now, when we compare our two answers, this one and this one, we may tell that this function or the limit does not exist. Feel free to comment in the comment section or in the comment box there, so that I may see where you are behind. But I hope with this no one is behind. We proceed to question B. So question B says limit of 1 over x minus 1 when x approaches 1. So let's do that. Find the limit as x approaches 1 of 1 over x minus 1. So we'll do the same. Let's start from the left hand side. Here we say when you substitute 1 there, you're going to have 0 in the denominator there. And never should you have a 0, any number being divided by 0. This is undefined. So what you do when you have these kind of functions, you try to insert the number which is closer to 1 when x is approaching either from the left hand side or from the right hand side. So this is not necessary. I was just trying to show you. I may rub it. Let us proceed. Let's say the limit of x, the limit of 1 over x minus 1 as x is approaching 1. So let us do this. Here we have 1, 2, here we have 0. So when x is approaching, here is from the right hand side. Let's say from the right hand side, it's coming here. Let's pick a number which is close, the closest number to 1. In this case, I'll pick 1.1. Then let's evaluate this function at 1.1. Where there is x, we put 1.1. 1.1 minus 1. So when you do this, you will see that this one, when you evaluate it, it will give you 0.1. So going back to primary, we can multiply this by 10 just to remove this decimal place there. This will give us 10 over 1, which is equal to 1. So this is the limit as x approaches 1 from the right of this function, which is equal to 1 when we evaluate the function at the function where x is equal to 1.1. So let us do it from the left hand side. we'll see what's going to give us. Then we can conclude whether it exists or not. So let me change the color so that you may be differentiating. So the limit as x approaches 1 from the negative, let's say from the left, of 1 over x minus 1. So let's draw a number line. This is 1, this is 0, this is 2. So when x is approaching 1 from the right, we pick a closest number, the nearest number to 1. So let's say this is 0.9. You may pick any number of your choice. It will still give you the same answer. So limit as x approaches 1 from the left. This negative here doesn't mean you have to put a negative number. This negative simply showing you where the limit is approaching 1 from. So let us put 0.9 where there is x. Evaluating this at 0.1, 0.9, you're going to have a negative 0.1 here. Again, I take you back to primary, multiply this by 10 just to eliminate this decimal point there. This will give you 10 over negative 10, which is equal to negative 10. So let's get back to the limit we found at first, where x was approaching 1 from the right. Oh wait, sorry. Here the answer is negative 1, not 10. That was just a minor mistake. Alright, we continue. Now let us compare the two limits. These two limits, they don't exist. Let me say the overall conclusion is that the limits from the right hand side and from the left hand side, they don't match, which means this does not exist. For it to exist, it should have equal functions, like equal limits when x is approaching it from the right hand side and from the left hand side. The limit should be equal. So now, in your question here, Mulungushi University students, don't know where this university is, but I'm just trying to help you because many students from there have been asking me questions about this same story sheet 1. So it says explain why the limits do not exist. So in your explanation, as mathematicians, we use mathematics language. I will just say limit, we say limit as x for a, the conclusion is this, as x approaches 0 of this function does not exist because the limit of this function as x approaches 0 from the left hand side is not equal to the limit as x approaches 0 from the positive or from the right hand side of this same function. Just like this, you get your A plus. Students, this is an A plus. So let's conclude for B. B, you say limit as x approaches 1 of this function does not exist. As simple as A, B, C, or 1, 2, 3. Because does not exist because the limit as x approaches 1 from the negative or from the left of this function does not equal the limit as x approaches 1 from the right of this same function. Just as simple as this, you get your A plus, students. So this is how you can conclude. This is how you can go about it. For more videos, subscribe and don't forget to share the video. Also comment on questions you want to understand. So we shall continue. We have just answered question 1, A and B. We will continue with this tutorial sheet. Thank you.